Okay, so once again, we got some data. Pediatrician wants to determine the relation that may exist between a child's height and head circumference. She randomly selects 5 children, measures their height and head circumference. Okay, so we've got height and head. Let's open this in StatCrunch. And we'll do another linear regression. We're going to pull up the regression menu for simple linear. We're going to be using height x to predict y. And again, we're going to just compute standard output. We're going to, again, have for each of the parameters for our beta 0, the intercept, our estimate is 10.92. I'm going to copy 4 decimal places, but I'm going to have to round it up. So 10.9242. And then for the slope, again, taking 4 decimal places, this I do not round up, so I'm just going to paste it and be done with that. Great. Standard error. The standard error, again, its standard error is up here. I'm going to take 4 decimal places for the standard error, which actually is just 0.07. Assuming normal probability plot, the standard error of B1, that's given right here, the standard error of B1, which is our slope, 0.0332. Paste it over. Okay, so now a normal probability plot suggests that the residuals are normally distributed. Test whether a linear relation exists between height and head circumference at alpha 0.01. So the null hypothesis would be that the slope is 0, which is to say beta 1 equals 0. The alternative is beta 1 does not equal 0. That's what we want to run. The null is beta 1 equals 0, alternative beta 1 not equal to 0. Remember, beta 1 is the slope. If the slope is 0, that means doesn't matter what value x is, y is not going to be affected. Okay, and what's the p-value for the test? Remember, the p-value for the test is given in our statistical output. 3 decimal places is 0.005, which is small and smaller than my alpha. Or the alpha, it says, is 0.01. So we do reject an h naught. Conclude there is a linear relationship between a child's head and height, head circumference. Yepers. Okay, now let's do a confidence interval for the slope and the slope coefficient, slope estimate. Let's go back to our options for our output. If you scroll down, you'll see, actually you don't have to scroll, you can either perform a hypothesis test or you can perform make a confidence interval. I'm going to create confidence interval at a level of 0.95 and click compute. You see my output is a little bit different now. In this section, instead of having an alternative and a p-value and a t-stat, I've got lower limits and upper limits for confidence intervals. Well, that's what I want. I'm doing a confidence interval for the slope, which is going to be, with 3 decimal places, 0.134, but I have to round it up to 0.135. And the upper limit, I'll just copy it exactly like that, 0.346. Okay, great. Suppose a child has a height of 26.5. What would a good guess for the child's head circumference be? We're going to use our model to predict. And to do that, we go to Options and Edit. We can scroll down a little bit, and here we have prediction of y. You can plug in a value for x. This is a height of 26.5. And we're going to just click Compute. And it's going to, in addition to all the other output now, it's going to give us, if you scroll down, predicted value. For the predicted value of for x value of 26.5, we had a predicted y of 17.296. 2 decimal places, okay. 17.29, that rounds up to 17.3. 17.30, not necessary, but for good measure, let's type it in. Great.